In the last example here, you're going to play a game with a friend. You're going to do a little gambling with your friend. You and your friend are each going to flip a coin. So you flip your coin and your friend flips his coin. If both the flips come up heads, then your friend has to pay you $10. If they're both tails, then he pays you $5. So if the coins match each other, then your friend is going to pay you. So that's the good thing for you. If the coins do not match each other, meaning you get a tail and he gets a head, or you get a head and he gets a tail, then he wins. You have to pay him $5. And so we're going to look at this from your perspective. Let Y be the amount you win. And we want to find the probability distribution for this random variable. So again, I'll think of all the possible values that Y could take, and we'll find the probability of each one. I'm going to start with 0 just because I like to include it. Although in this case, there's no way that the probability can come out to be, that the random variable can come out to be exactly 0 here. Depending on what the coins show up, either your friend's going to pay you or you're going to pay your friend. And there's no outcome that leads to a 0 exchange of money. And so the probability there is 0. The probability that you're going to make $5, well, to make $5, let's see, you have to get both coins being tails. So that's the probability of tail, tail. And the chance of both coins showing tails, that's 1/2 times 1/2, is 1/4. So that's your chance of making $5 out of this experiment. Probability of you making $10 out of this experiment. For that to happen, both flips have to be heads. So you've got to see 2 heads there. And so again, the probability of 2 heads is 1/2 times 1/2, or 1/4. Now, if the coins do not match, then you have to pay your friend $5. From your perspective, that's a negative $5. We call it a win of negative $5, but you're really losing $5. So the way that happens is if you show a tail and he flips a head, or if you flip a head and your friend flips a tail. So there's 2 possibilities there, but each one of those has probability 1/4. So 1/4 plus 1/4 is 1/2. So those are all the different outcomes that can happen, and those are all the different values of the random variable. Those are all the different payoffs that can happen in this experiment. I listed 0 even though it's not really a legitimate outcome here. I just wanted to calculate it through. There's a 0 probability that no money is going to change hands here. The probability of getting $5, remember we're looking at this from your perspective. So $5 win for you would happen if there are 2 tails. To get 2 tails in a row, or to get both your coins to come up tails, there's a 1/4 chance of that. To get 2 heads in a row, which is what you need to make $10, there's also a 1/4 chance. And then the probability of getting negative $5, that means that your friend takes $5 from you. That has to happen if you flip a head and he flips a tail, or vice versa. So each one of those combinations has a 1/4 chance, meaning that there's a 1/2 chance that you're going to end up paying him $5. So that's how we calculated each one of those probabilities for each one of those payoffs, and that's considered to be the probability distribution for this random variable. So that's our last example, and that wraps up this lecture on random variables and probability distributions. This is part of the larger probability series here on Educator.com. My name is Will Murray. Thanks for watching. Bye-bye.